Hello everyone, so today we're starting a new chapter in Maths, that is sets. So let's get started. So before we get started, we have to have this vague idea of what a set is. So set is a well-defined collection of objects. So let me give you a live example. Just go outside of your house and just look around. You find a group of pigs, a group of dogs, and a group of aunties. So this you can call as a set because they are a collection of things, right? And it's also well defined because you can't find a dog in the bunch of pigs, nor can you find a pig in the bunch of aunties. Well, maybe, but yeah. So that's what is a set. And there are also like other non-lively examples like odd numbers less than 10 and then rivers in India. So there are like countable amount of rivers in India, right? So they come under sets. And then vowels, A-E-I-O-U, they're also a part of a set. So that's the introduction. So let's move on with the chapter. So throughout this chapter you'll have a lot of the symbols that you'll have to use. So I've just given them in a table so that you can have a better understanding of them. So n means a set of all the natural numbers, z means the set of integers, q rational numbers, and r for real numbers, z for positive integers, q plus for positive rational numbers, and r plus for positive real numbers. So it's pretty obvious. Yeah, you just have to mug it up. I'm sorry, I can't help you with that. So now we have two forms in how to represent this this type of set. I mean, how you represent a set. So there are two forms. So first in the roster form and second in the set builder form. So obviously as it's max, you might not have a group of aunties or pigs as your set. So obviously you'll have numbers. So that's how you're going to write them. So in roster form, all the elements of a set are listed. The elements are being separated by commas and are enclosed with braces. So this is how you represent a set in a roster form. So let's just say give me the set of even numbers less than 7. So what are the numbers? 2, 4 and 6, right? So now the 2, 4 and 6 are the elements of your set, which means the objects in the thing. So when you say a group of pigs, you have pigs. Each pig is an element. So say likewise here you have the numbers 2, 4 and 6 as your elements. So those are your elements and you have got to separate them with commas and then enclose them with braces. So that's how you represent them in roster form. And then you have your set builder form. So all elements of set possesses a single common property which is not possessed by any other element outside the set. Which means that now if I ask you a set of positive integers, positive even integers less than 7. So when I give you that, you tell me that the set contains these elements 2, 4 and 6. So in any other question you can never have this answer, right? Like meaning that for even positive integers less than 7 you can only have 2, 4 and 6, not 5, 3, 7 or something else, right? So that's the only standard answer that you can give me. So that is what is a set builder. So that question is what is the set builder. So if you give me 3 elements 2, 4 and 6, I can make a ton of set builders, like even integers less than 7, even integers less than 8, and then positive integers that lie between 0 and 8. So you have a lot of them. So in set builder you have this kind of freedom of framing the question. Like you just have this fake virtual freedom that you are never going to get in your life, that you can raise questions against anything, against the government, against the questioner himself in the exams. So yeah, so that's what is a set builder. So if I tell you x such that, so those two dots means such that, okay, that's the meaning of those two dots. So x such that, x is a vowel in English alphabet. So this is the thing. So what do you write for it? What is the answer for it? What is the answer for it? A-E-I-O-U, right? So for this particular question you have only one answer, but you can have numerous other questions on these 5 elements. So that's what is a set builder. I hope you are understanding and like following me. If not, it'll be hard because yeah, I just hope you're following me. Yeah. So now let's solve a few example questions. I mean exercise questions, sorry. Yeah, so I'm and don't expect me to answer like all the questions because I'm lazy and I've not got all my life to make a simple video. So yeah, I've given like most of the hard questions from each exercise, so that will kind of help you out with solving the rest. So yeah, so the first question, which of the following are sets? So the collection of all months of a year beginning with the letter J. So what are the months that start with the letter J? January, June, July, that's it, right? So that's a set. So here you are representing all of them in a roster form. Okay, so you have the elements, commas between them, and then enclosed them with a braces. Yeah, so that's the first question. And then the collection of 10 most talented writers of India. So this is not considered a set because opinions differ from person to person. Like, I'll tell you a few 10 most talented writers of India, and the other person would think that some other 10 people are the most talented. So it varies from person to person, right? So one may be a Marvel fan while the other is a DC fan. So that doesn't make out that I'm wrong and he's right, or he's wrong and I'm right. But still, Marvel is the best. I'm telling you, Marvel is the best. Sorry, DC people. Like, sorry you have such bad taste, but yeah, Marvel is the best. Okay, just understand that Marvel is everything. Okay, yeah, I got a little heated with that thing, but yeah. So that's the thing. Each person has a different opinion, so we can't just argue and make controversies and fight. So we'll just conclude that it's not a set. Yeah, and there's another note point that I think will work for you all is that if questions are asked with adjectives used to describe the elements, then they are not a set. So here they've given the collection of 10 most talented writers. So talented writers. So talented is an adjective used for the writers, right? So whatever question that follow from an adjective to the noun or stuff, so those are not considered a set. So just remember that, and that will help you in a lot of questions. So next, the second question is, they've given a set A, 1, 2, 3, 4, 5, 6, and they've asked to insert the appropriate symbol of belongs to or not belongs to. So those symbols means belongs to and not belongs to in the blank spaces. So 5 dash A. So what do you think 5 is? What do you say? What relation does 5 and A have with each other? So 5 is an element in A, right? So you write it as 5 belongs to A. Okay, so that's how you do it. So in the set A, you have all these elements 1, 2, 3, 4, 5, 6, right? So you have 5 in the element section. So 5 belongs to A. And then does 8 belong to A? No, because it ends with 6. The set A ends with 6, so 8 does not belong to A. And then the next question, write the following sets in roster form. So they've given a set X such that X is an integer and it lies between -3 and 7. So how do you write that? So they've given that X is an integer. So minus value, 0 value, plus value, all are considered. So, and then they've given X lies between -3 and 7. So what are the integers that lie between -3 and 7? If things are hard for you to like just imagine and write, you just make a number line from 0 to till 10. That's the max they last. So from 0 to 10 and 0 to -10. And then you just write the borders, I mean the boundaries, and then write all the elements in between them. So when it comes from -3 to 7, just draw a number line from -10 to +10, and then you can have the elements in between them. So after -3, you have -2, -1, 0, 1, 2, 3, 4, 5, 6. Yeah, so all these are the elements in set A. And then there's another question, the set of all letters in the word trigonometry. So in the word trigonometry, what are the letters that you find? So you have E, G, I, M, O, R, T, Y. And there's another point that you have to note down, that you don't have to repeat the same element once or twice, twice or thrice in the set. Like when you're simplifying the set, the final outcome must always be a simplified set, meaning that there shouldn't be two same elements in the set. So if you have a set 1, 2, 1, 2, then your simplified set must be 1 and 2. Okay, so you don't have to repeat the same elements in the set. So here as well, you have 2 O's and 2 T's and all of that. So all of those repeated elements must be simplified and written only once. So that's a second note point that you have to remember. Next, write the following sets in the set builder form. So now they've given sets in roster form and they're asking you to convert them in set builder form. Now here you have a lot of freedom, as I said previously. So you can frame this set builder in any way you want, right? There are no like specified answer. There is no specified answer that you can only write it in this way. Like you have so many n number of ways you can write the answer for this. So I've written one such way. That doesn't mean that's the only way. Okay. So just when I'm using the way, I just remember that Reddit meme thing. Gosh, let's get back. Yeah. So A, the elements are 3, 6, 9 and 12. So what do you comprehend from this? They are multiples of 3. Yes, they are multiples of 3, and they only lie till 12, which means, so 3 into 4 is 12, so it lies below 3 5s, which is 15. It lies below 15, right? So you can write it in this way: 3x such that x is a natural number and x is less than 5. So 3x would be your general kind of thing, and you're substituting the x value in that general value and then getting the set. So that's how it works. So in 3x, you're substituting the x values. So what value should you substitute? You should use the upcoming sentences. So x is a natural number. So in that 3x, only natural numbers are supposed to be used. And x is less than 5. So 1, 2, 3, 4. These are the 4 values that you can use for x. So 3 1s are 3. You get it in the element. 3 2s are 6. 6 is an element. 3 3s are 9. 9 is an element. 3 4s are 12. And you have that in the element section as well. So that's how you do it. And then you have 2, 4, 8, 16 and 32. Now this one looks like the powers of 2. So here again you can use the same kind of method. So you can have a general form kind of thing. So 2 power x and conditions for that x. So x is a natural number and below 6, because 2 power 5, that is 32, is the maximum value in the element. So that's how you do these problems. And then next, now we'll see types of sets. So the first type is empty, void or null set. So you can call it in all these 3 terms. So empty set, void set, null set, all of them are the same type of set. Okay, so this means that a set which does not contain any element, basically a void space. So it doesn't contain any element, like it's just waste of time. Yeah. So let A, so we'll have a few examples for them. So let A be a set where x such that x lies between 1 and 2 and x is a natural number. So how do you so what are natural numbers? 1 2 3 4 5 6, right? What lies between 1 and 2? Nothing. So how do you define this nothing? We can't, right? So that's why these mathematicians found a smart way, with quotations, smart way for telling that there's nothing, or it's empty, or it's void. So that's why there is something called an empty set or a null set. So A is an empty set because there is no natural number between 1 and 2. Then and then the other examples are the same as well. You can just go through them. Yeah, I'll give you some time. Done? Are you done? Are you done? Can I move on? Yeah, moving on. Bye. So the second type are finite and infinite sets. So there are 2 types, finite and infinite sets. So what is a finite set? A set which is empty or consists of a definite number of elements in a finite set. So when you look at a bunch of pigs, so you are talking about a finite number of pigs, right? So the finite number of pigs that I see would be 5 or 6. Not that you're telling pigs in general, which are infinite in number. So you're just concentrating on the 5 or 6 pigs that you see, which are a finite set. So let W be a set of the days of the week. So W is a set of days of the week, meaning the number of days in a week: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Yeah, so there are 7 days, which is finite. So that's a finite set. And then infinite sets, as I previously said, pigs in general, they are infinite in number, because we don't go around counting pigs from Chennai to Mumbai to Agra to Korea to Canada. We are not insane. So we wouldn't do that, would we? I don't think so. So yeah, so those things are all called infinite sets. A set which is not empty or consists of an infinite number of elements is called an infinite set. So let G be the set of points on a line, and G is infinite. How many points make a line? If I ask you this question, you'll ask me, are you insane? A point is made of infinite lines. I mean, shit. I messed up. I messed up the whole line. A line is made of infinite points. So let's move on. So that's one type. And there's another note point you've got to consider, that all infinite sets can't be described in the rooster form. For example, the set of real numbers can't be described in this form because the elements of this set do not follow any particular pattern. So all infinite sets can't be described in rooster form, because now let's take a set of real numbers. So when you take a set of real numbers, you don't know where it starts, nor where it ends, nor the intervals that you have to leave. So it's not that you can write 0, 1, 2, 3, because between 1 and 2 you have infinite real numbers. So it's just all kind of in mysteries and mysteries and mysteries. It will lead you into a, an ocean of mysteries that you will never be able to solve. So in the case of real numbers and all, you can never describe them in sets, I mean roster form. Okay, that's what they said. Yeah. And then equal sets. So the two sets A and B are said to be equal if they have the exactly same number of elements and we write them as A equal to B. Otherwise, A not equal to B when they are unequal. So set A 1 2 3 4 and set B 3 1 4 2, which is just in a jumbled order. So we are not blind. So we just write it as A equal to B. So that's just obvious. Like if they have the same sets, they are equal. Bas, khatam, khel khatam. So that's how it is. And also, as I previously told you, you should never like leave the sets with repeating elements. So set B, in the example 2, set B, you have to simplify them as 1, 2 and 3, and again they'll be equal. And then subsets. A set is said to be a subset of a set B if every element of A is also an element of B. So one set is said to be a subset when every element of A is present in every element of B. Wait, I just said the same line but slowly. Wow, what an explanation. Thali bajao. Okay, so I'll give you an example. Okay, I'll tell you. I've got an example. So if I say a set of golden retrievers, I'll give you two sets: a set of golden retriever and a set of dogs. So are they the same? No. But are they related? Yes. So a set of golden retriever is also present in the set of dogs, right? So because golden retrievers are dogs and they will come under the set of dogs. So this is what is the meaning. So the set of golden retrievers is a subset of the set of dogs, right? You get me? Because it on the whole is present in the other set. So that makes it a subset. So that is the meaning. And you have other examples as well. So now we have got to the climax of this lesson. So the main major turning point of this lesson. So intervals as subsets of R. So you have three kind of representations. So first one is the closed interval. So you have two closed brackets, which means that A and B are also included in that interval. So interval is nothing but, so I give you x lies between 1 and 3. So 2 is an element, right? So this lies between 1 and 3. That is an interval. It lies between this and this. So you can say Punniyin Selvan movie lies between 4 a.m. to 6 a.m. Meaning that this story's duration is for 2 hours. So that's the so closed interval means you're including the boundaries as well. So when I say closed interval a comma b, you're taking the x value to be a and then b and then the elements between a and b. So that's what means when you say a comma b closed. Okay, then open interval. So in open interval you exclude the boundaries and then take the middle part, meaning that when I say a comma b open interval, you do just from a to b, all the parts between a and b but not a and b. So when I give you 1 to 3 closed, you have 1 2 and 3 as your answer, but 1 to 3 open, you have just 2 as the answer. And then you have open close intervals and close open. So here wherever you have the closed bracket, you include that. Wherever you have the open bracket, you exclude that. So closed a open b, in that case you have a between a and b and no b. But then if you have open a and b close, then you'll have a to b and then b, but never a. So that's what these brackets mean. Next is your power set. So the collection of subsets of a set A is called power set of A. It's denoted by PA. In PA, every element is a set. So it's just self-explanatory. So just look at this example. So A set contains 1 and 2. So the power set of it would contain, so power set is the collection of all subsets of a set A. So when I tell you a set of golden retrievers, a set of Pomeranians, a set of lab, a set of pug, a set of huskies, a set of German shepherds, a set of shih tzus, and so on, they all come under a set of dogs, right? So all these sets which I told you earlier would be subset of the main set, the set of dogs. So that's how you represent them. So P of A would be 1, 2, 1, 2 and a null set. That symbol that you see here, the symbol that you see is to represent a null set. So either you have these brackets or else you use this symbol. So that's what this is. So a set of golden retriever and lab can be one set, right? So just like that, you also have the 1, 2 also as a set. So all the subsets taken as elements is called a power set. That's the OG definition. Yeah. So that's that. And then how do you find the number of sets, number of elements in a power set? So you just use 2 power the number of elements in the normal set that is given. So the given set is 1, 2. So we have 2 elements, right? So you just substitute it in the power 2 power n 2 power 2 4. So that's how you find that. Next is your universal set. So the set containing all objects or elements and of which all other sets are subsets. So even this comes when we are talking about the thing. So the set of labs, set of golden retrievers and all, what is their universal set? What is their ultimate set? The set of dogs, right? So that set of dogs is the universal set. So the set containing all objects or elements is called a universal set. So the set of triangles would be the universal set for the set of right angles, or the set of equilateral triangles, or the set of scalene triangles. So that's how that is. And then the set for the set of rational numbers is the set of real numbers. So in the set of real numbers, you also have rational numbers. Venn diagrams. So now we have reached the ultimate topic in this lesson, Venn diagrams. So Venn diagrams makes your life so much easier. Like from this hell of a chapter, Venn diagrams are the best. Like I'm telling you, Venn diagrams are the best. They make your life so damn easy, like so damn easy that you'll just understand. Yeah. So universal set 1 to 10. So 1 to 10 is the universal set, and A is a subset. So 2, 4, 6, 8, 10. So all the sets. So the universal set is always shown in a rectangular box. It can also be square. Like I don't mind. It can also be a square or whatever. It just has to have that kind of shape. Okay. So that's usually represented in rectangles or squares, and the sets are represented in circles. So now you have this example. So A is a subset and use the universal set. Universal set is 1 to 10. A is a subset 2, 4, 6, 8 and 10. So in the circle you have the elements of the subset and the rest elements outside the circle. So that's how you represent them. So 2, 4, 6, 8 would go inside the circle because it's in the set A, and then the rest elements from the universal set outside the circle but inside the square because it's in the universal set. So that's how you represent them. And then another example for you. So now you have 2 sets, A and B, but B is present within A. So first you draw B. B is present within A, meaning that B is a subset of A. So whatever sets that are subset of another big set would be a circle inside that big set. So inside A we have B, which is 4 and 6, and A contains 2, 4, 6, 8. So that will be that. Whatever elements are not in B should be in A but out of B. So that's how you draw that circle, this circle. And then now you still have elements that are not in A as well. So those would come out of A but inside the box, which is the universal set. So that's how you represent them. Next, operation of sets. So you have 2 main operations of sets, union and intersection. So union. The union of set A and B is the set C, which consists of all those elements which are either in A or in B, including those which are in both. In symbols, we write A union B equal to X such that X belongs to A or X belongs to B. So that's how you write them. So U is the symbol that is used for union, and for intersection you have the inverted U. So union of set, by that they mean the elements that are present in A as well as B. I mean A or B. So just remind this key point. So for union you have or, intersection and. If it's A or B, it's union. A and B, it's intersection. So the elements present in A or B is the union set. So A or B meaning that it can be present in A or it can be present in B. So that's how you represent them, meaning that all elements in A plus all elements in B. So that's the representation, you've got the representation of it as well in the form of Venn diagrams. So it's present in A and in B. So the whole part is shaded. Next, we'll see an example. So 2, 4, 6, 8 is set A and set B is 6, 8, 10, 12. So what is A union B? As I've said, present in A or B, meaning all the elements. So you just write them 2, 4, 6, 8, A done, and then 6, 8 already done. So from B, 10 and 12. So all of that would be in A union B. So that's how you do the union of sets. Next, some properties of the operation of union. So you have a few properties. So you know, right, commutative law, associative law, identity element, and then idempotent law, and then law of union. So that's that. So A union B is equal to B union A. So eat breakfast and then dinner, or dinner and then breakfast, doesn't matter. All they do is get into your stomach and become some chime and get out. Yeah, so there's nothing that matters. So that's what commutative law is. And then associative, you just play around with the brackets. So A union B bracket union C, or A union bracket B union C, both are the same. Yeah. And then A union null set. So A or nothing. What will you get? A plus nothing, which is nothing but A, right? So that's what they have said here. And then A or A, an idempotent law, A or A. What do you get? A again. So you're like set of cats or set of cats. Set of cats plus set of cats. Set of cats. So that's the idempotent law. And then universal set or set of A. What will you get? Universal set. Like a set of dogs or a set of golden retrievers. That means set of dogs plus set of golden retrievers. Meaning set of dogs. So it's just a verbal understanding that you need to adapt or get. Because if you just have that, you'll understand things way better than anyone else. Next, intersection of sets. Intersection of two sets, A and B, is the set of those elements which belong to A and B. As I said, A and B. So, present in A as well as present in B, which means the elements that are common between A and B. So, you also have the Venn diagram representation. So, it's present in A as well as in B. Here's an example for you. Just from this previous example, tell me, 2, 4, 6 is set A. Set B, 6, 8, 10, 12. So here, what are the elements that are common? 6 and 8, right? So this will come under the intersection. Whatever is common between A and B, that is the intersection set. So for A union, as I said, you use this upside U symbol. So that's how you represent that. Next. So even for this, you have the properties of operation. So A intersection B or B intersection A, both are the same as it is. Set of dogs and set of golden retrievers, or set of golden retrievers and set of dogs, both are the same. And then associative property, just playing around with brackets. However the brackets are, it's going to be the same. Then null set intersection A. So what is common between nothing and a set A? What is common between them? Nothing. Okay, what is common between nothing and a set of gossiping aunties? Nothing. Right? That's just the thing. And then what is common between a universal set and a set A? It would be set A, because the other parts of the universal set would not be present in set A. Right? So what is present in both of them? Set A. The universal set contains everything and set A contains only A elements. So then what will be common in both of them? Just set A elements. So A is kind of smaller, right? So the smaller elements would only be common with the universal set. So that's the idea. And then in set A, what is common with set A? A. So that's that. Next. And then you have this distributive law. So A intersection B union C would be A intersection B union A intersection C. Just like 3 into x plus 3 would be 3x plus 3 into 3. 3x plus 9. So you're just doing the same things that you do with the normal numbers, but here with intersection and union. So that's the same thing. Next, difference of sets. The difference of sets A and B in this order is a set of elements which belong to A but not B. So in A, I'm giving you example 1 to 10. And in B, I'm giving you an example of 5 to 10. I mean elements of 5 to 10. So in A, the elements are from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in B, you have the elements 5, 6, 7, 8, 9, 10. So now give me the elements that are present in A but not in B, meaning that you subtract the elements of B from the element of A. So in A you have 1 to 10, in B you have 5 to 10. So what do you get? 1 to 4. 1 to 4 will be the elements that are present in A but not in B. So what did you just do? Subtract the elements of B from the set A. So that's exactly what you have to do. You also have the Venn diagram representation of the, what is it? What is this? Of the sets. So we'll see an example. Another example. So A 1, 2, 3, 4, 5, 6 and B 2, 4, 6, 8. So now A minus B. You subtract all the elements in A, all the elements in B from A. So A minus B, you subtract B from A. B minus A, you subtract A from B. So A minus B. So you, in A minus B, you subtract B from A. So what are the elements? 2, 4, 6 and 8 you subtract from A. So what will you get? 1, 3, 5. Because 2, 4, 6 are already in B. Now B minus A. What are all in B? 2, 4, 6, 8. So and in A 1, 2, 3, 4, 5, 6. So here from B you take out 2, 4 and 6 because it's present in A. And then whatever is left would be 8, right? So 8 would be the element in the set B minus A. Now you might raise a question, why is it not 1, 3, 5 and 8? You might have this kind of doubt. If you don't, then that's totally awesome. Just don't confuse yourself now, because yeah, you're already too clear. So don't, like, just skip this part. But if you have this doubt, stay there. So I'll clear this out for you. So if you have this doubt, why not 1, 3, 5 and 8? Then just pay attention. While you have this kind of confusion, all that you do, I'll give you the easiest trick, okay? All that you do is find A intersection B. So what is A intersection B? 2, 4, 6, right? That is A intersection B. So now when they give A minus B, you do A minus A intersection B. When they give B minus A, you do B minus A intersection B. So this is a trick for all of you who get confused with student 1, 3, 5 and 8 come as the answer. So this is what you do. Next, complement of a set. So what's complement of a set? Nothing but, if I give you set A and ask you the complement of this set, you say anything but the set A. You give the elements of anything but the set A. So in the questions, what they'll give is that they'll give you a universal set, and then they'll give you set A, and then ask you for the complement of the set A. What do you do is you just subtract the A elements from universal set. So U minus A would be your complement of A. So that's the simple explanation. Okay, A dash would be U minus A. So if you're wondering what is this power kind of thing used for A, then that's nothing but A dash, meaning A complement. So for this A, how do you write a set builder form? X such that X belongs to union but does not belong to A. So that's how you understand that. And then now, not just the set A. If they give you in complement of A union B, then you just do the same, except that first you took just set A, now just take set A union B. So universal set minus A union B. So that's how simple it is. Okay, so that's how you do it. So for any two sets A and B, the complement of A union B can be written as A complement of A intersection complement of B. So you can write it in that way as well. Same way, complement of A intersection B could be written as complement of A union complement of B. So just remember that the symbols are changing from U to inverted U and from inverted U to U. Okay, there's another one such trick as well. So complement of A complement is nothing but A. It's just like A power n to the whole power 1 by n. So what do you do? A power n by n, which is A, right? So that's the exact example, or that's the exact way they are doing this as well. So complement of A complement would just be A by cancelling out with the complements. Next, this one is an important part in this chapter, De Morgan's laws. So the complement of the union of two sets is the intersection of their complements, and the complement of the intersection of two sets is the union of their complements. So this is the exact thing that we explained in this first point. First point here, that's the explanation. So that is just the De Morgan's law. The complement of union of two sets is the intersection of their complements separately, and the complement of intersection of two sets is the union of their complements separately. And then you have properties for complement sets as well. So A union not A would be universal set. So just imagine again, you have a set A, and then what do you call a set that is not A? U minus A, right? So what? So you're given A set A and not set A. So A intersection not set A would be universal set, because that is the total part, A and not A. That will give you the total part, which is the universal set. And then when you have A intersection A not, meaning that there's nothing in common between them. There's A and there's not A. So then you get the null set. So that is the complement law. Then De Morgan's law we have already seen. And then law of double complementation, we have seen it again. Just like powers, you cancel them out. And then the law of empty set and universal set. You have this as well. What is the complement of nothing? So what is the opposite of nothing? Everything. So what is everything? The universal set. And what is the complement of everything? What is the opposite of everything? Nothing, which is a null set. So that's the last law then. Now we have a few practical problems on union and intersection of two sets. Just try to imagine the whole Venn diagram in your brain. Okay, that's what I'm doing right now. And if you listen to all of my all my guidings, having all these pictures in your brain, then it would be so much better for you, because whenever I'm speaking stuff, whenever I'm teaching stuff, I already have something going on in my brain. So I'll have that picture in my brain. So with that, I'll explain it to you. So just try to imagine stuff. Okay, so just imagine there are two sets, A and B. So in the first case, A and B are separate sets. So in that rectangle, there are two separate circles. So A intersection B is null set. There is nothing common between A and B. So due to that, what is the A union B? That is the elements in A or B. Element in A plus element in B. Number of elements in A plus number of elements in B. So the first one is done. Then the second one, okay, just take two colors, yellow and blue. Okay, just do this. Take yellow and blue. Okay, so now what do you do is draw these two triangles as we have seen in that picture, and then now first color the first circle with green, blue color, and then color the second circle with yellow color, like completely. First circle completely, second circle completely. Now you'll see that the middle part has turned to green. Yes, it's not a magic, but whatever. It's just the primary colors trick, but whatever. This will work in this example. Okay, so just take this like some kind of activity and try. Like it's fun, dude. Just do it. Okay, so now you'll get this color to be green, right? Meaning that there is blue once added plus a yellow part once added, meaning that it's added twice. But you only need the one time count. You only need one layer. Okay, you don't need blue layer as well as yellow layer. You only need one layer. So what do? You color one circle completely with blue, and then the other half circle you in the second circle you just color the half part with yellow, right? If you need just one layer to be done. So for that, what are you doing? You're subtracting that additional yellow part that you're doing for that middle section, meaning that you're subtracting that one intersection part. So that's the exact thing that you're doing even in this formula. So you're subtracting one n intersection b. Okay, so n of a plus n of b minus n of a intersection b. So now I hope you understood that. Like if you did this activity, you'll surely understand that. Like if you are still puzzled and all, just rewind this video, do that activity, and then follow my words as well. Then you'll get the clearest picture of all time, and you'll never get confused in this aspect. Okay, so just try it out. Okay, next, if A and B finds, then n of A intersection, I mean A union B union C would be n of A plus n of B plus n of C minus n of A intersection B, n of B intersection C, n of A intersection C, and n of plus n of A intersection B intersection C. So for this one, you'll have to get a bigger understanding. So you'll have to take the pencils and colors for this. Okay, so this one is going to be like twice as fun. Okay, if the first one was fun, this is going to be twice as fun. Okay, I promise. Yeah. So now draw a rectangle and three circles. So these three circles have to be like this, and then do whatever I say. Color n of A with yellow, color n of B with blue and color n of C with red. Okay, so n of A with yellow, n of B with blue, n of C with red. Okay, so next, like the complete circles. Now in the middles, in the mid regions where you have the loopy stuff, wherever you have the loopy stuff, there you will find different colors, right? So those are extras. So wherever you see the extra colors which you didn't color, they are to be what? Tell me, they are to be taken out because they are extra layers. What do we need? Just one layer, just one basic layer with the same colors that we gave to the picture. So what do we do? One layer from n of A intersection B we are taking out, and then one layer from n of B intersection C we are taking it out, and one layer from n of A intersection T we are taking them out. So now when you take all these layers out, what do you find? You find that the mid area which is the n of A intersection B intersection C is completely empty, completely white. So what do? You add one color to it. So let's just say we are adding black to it. Okay, so what are you doing? You're adding. So you do plus n of A intersection B intersection C. So just try out this activity and it will make sense, like, so better when compared to doing all the derivations and stuff. I don't think they'll ask the derivation and things for this, but yeah, more than like just the more than just deriving and mugging up. Like, what I want you to have is the sort of understanding to the subject more than just mugging up, reading, studying, and doing all those stuff. So you should have a better understanding on the concepts. Okay, so that's what I'm trying to give you here. So just try out this activity. I'm not doing it for you because I want you to do it on the spot and understand by yourself, right? That would make you remember this kind of thing much better than to just listen or than to just write. Okay, so that's how these two are going to look. And then the last two formulas: n of A equal to n of A minus B plus n of A intersection B. So what is n of A minus B? So the half moon like structure that is present. N of A minus B is nothing but n of A minus n of A intersection B. I've told this, right? So n of A minus B is nothing but n of A minus n of A intersection B. Like, you're taking the part that is common from A to get n of A minus B. To get n of A minus B, what are you doing? You're taking out the intersection part of A. So n of A minus B is equal to n of A minus n of A intersection B. So just take the minus n of A intersection B to the other side. Then what will you get? The equation will come out to be n of A is equal to n of A minus B plus n of A intersection B. Same way for B as well. So n of B minus A, what is it? N of B minus n of A intersection B. From the B set, you're taking the intersection part to get n of B minus A. So n of B minus A is equal to n of B minus n of A intersection B. So now you're taking the minus n of A intersection B to the other side. So you'll get n of B is equal to n of B minus A plus n of A intersection B. So with this, we have come to an end, and I hope you all enjoyed watching this. So thank you so much, and be nice enough to subscribe and like and share. Please. Thank you. Bye.